We have 1.5 kilometers squared, and we're supposed to change it into so many meters squared. Boy, isn't it hard to know whether it's miles or meters when you're, I guess we just got to know they're sticking with the same unit here. We're not going to miles, we're going to meters here. All right, so if I want to change this over, how many times am I going to have to do my conversion?
2.
2. And how'd you know that, Quinn?
Because it's 2 squared.
Yeah, you got the square in it. The reason this matters is when you get into geometry and you're going to be converting figures, you'll have like, you might have a rectangle and you're converting the units from meters squared to centimeters squared or something, and this is one of the reasons why they're having you do this, is you use this in geometry a lot when you're doing actual hands-on problems. All right, so here we go. We have 1.5 kilometers squared. That's the same thing as kilometers times kilometers, isn't it? And so that means if I want to get rid of each of those kilometers, I'm going to be multiplying twice because each one of those has to cancel out, right? That one might cancel that one out, and that one might cancel that one out, right? Now, I want to end up with meters in my answer, right? So I know when I get done, I want meters squared over here. That means I need a meter on top of each one of these, don't I? What do we know about kilometers and meters? What relates those two things? How many meters in a kilometer?
1,000.
1,000, yeah. So we'll say there's 1,000 meters in 1 kilometer, and I'm just going to use that math fact twice. That's the good thing. You don't ever have to go past the unit with these things. You can just take everything to the unit and then, keep going with it if it's another weird thing on the other side. But this one's kind of a simpler one. All right, so now, if I want to, I can take and make this a fraction, right, so that I'm looking at it, because it's easier for our brains to handle. If we're multiplying a fraction times a fraction times a fraction, we know to go all the way across the top and multiply, and all the way across the bottom and multiply. On the bottom, all we have is 1 times 1 times 1. So we're just going to have a 1 on the bottom. Now I'm going to come down here because I'm not going to have enough room to write all that, am I? 15 times 1,000 times 1,000. I'm going to write the 15 down. How many zeros go after it?
6.
Yeah, 3 here and 3 more here. That's 6 in all. 1, 2, 3, 4, 5, 6. And it's over a 1, so the 1 really doesn't matter.
Isn't it 1.5?
No, you remember we're going from kilometers, which is a really big unit, down to a small unit. We're changing a really big unit into a bunch of little smaller units, so it should be a really big number. And that's the thing about these conversions. If you get kind of confused about that, have I canceled out all my kilometers here, and do I have meters on top now? So I can tell if I use these, this is what's good. This is what it's good for. If you get confused about should that be a really small number or should it be a really big one, well, if I set these fractions up, I really don't have to worry about that. I just multiply and I'm done. It's like my brain has less to keep up with because I'm putting little facts down that I know on paper.
Well, I meant like 1.5, like that's, you go from there, right? And
Oh, I'm sorry. You're right. I didn't see that it was 1.5. I'm so sorry. Yeah, I didn't see that. After I wrote it down, I looked at that as 15. You're right. I just, from here, didn't notice that dot there after it. Okay. Yeah, okay, so it's 1.5, and you're going to add 6 zeros onto it. So what I could do is just move my decimal place to the right, 6, correct?
Yeah.
Instead of adding 6 zeros, since there is a decimal involved. 1, 2, 3, 4, 5, 6. There's where my decimal point's going to be, and for every little indentation there, we'll put a 0 in it. So it ends up being 1, 5 with 5 zeros after it. Thanks for catching that. I'm sorry, I didn't. Once I write it down, if I don't see it, I totally start doing a different problem. So it's 1,500,000 meters squared, which would make sense. If you know there's 1,000 kilometers in a meter, if you just did it one time, it would be move it over 3, but since you did it 2 times, you got to move it over 3 more. So again, if you can do these faster, do it faster. Use these conversions for times when you need to make sure you're not confused. Or, if you just need it is to kind of keep you on track. They keep you on track no matter what, so that's what's kind of good about them, is even if you don't need to use them and you use them, you should still end up with the right answer. I would practice it on things you know how to do so that you're making sure you're doing it right. Let's do another one. Y'all have a choice? Y'all have one there you want to do? You want to do number 11 since it's got another decimal in it, maybe? let's do that one. 0.333 kilometers squared is equal to how many meters squared? Now I know that there's 1,000 kilometers in a meter. So if you think about it, you know that you're going to move it over 3 times, but you got to do that twice, right? If you're just trying to do it really fast in your head. But let's say you can't do it fast in your head. You can't see that it's multiplied by 1,000 twice. If you see that it's multiplied by 1,000 twice, you just move it over 3 spaces and you get 333, and you move it over 3 more and you get 333,000. So you can do it quickly in your head, but let's say you have trouble with that. Then this is when this method is great. I've got kilometers squared, so it's like saying I've got kilometers times kilometers. I'm going to go ahead and make this a fraction and put it over 1 just so I don't have to do it at the end. Now, if I want to get rid of those kilometers, I need 2 copies in the denominator to get them to cancel out, right? See, that one would cancel that one out, and this one would cancel this one out. But I need to end up with meters squared over here, so that means I need 2 copies of meters in the numerator. Reagan?
What is like the 3 number? Like it would be kilometers.
What is the?
3 over?
Oh, when I said that, that was like if you're trying to do it really quickly in your head. You know, 1,000 kilometers. 1,000 meters is 1 kilometer. I may have done it wrong. This is why I like the fractions, is I get them backwards in my head. Let me show. We'll talk about. Let me answer that question after we do it the long way. That way I won't make sure I said it right. Okay. All right. So there are 1,000 meters in 1 kilometer, right? 1,000 meters in 1 kilometer. I did say it right. I just wasn't sure I did until I did the conversion thing, because I get confused with these about which direction to go to sometimes. If you look at on the bottom, don't we have 1 times 1 times 1, right? Which is 1. And I got meter times meter, which is meter squared. Now, here's what I was saying. If you didn't need to do all this, 1,000 kilometers is 1 meter. See, 1,000, here we got, no, 1,000 meters is 1 kilometer. I keep saying it the wrong way. 1,000 meters is 1 kilometer. If I were to multiply 0.33 by 1,000, since there's 3 zeros, wouldn't I move it over 3 spaces to the right, the decimal place? That's just for this first one. But then now that I've got another one, I would move it over 3 more spaces, which would mean I could fill in with 3 zeros. That's what we're doing here. We're just taking a little longer to get it done. So 0.333 times 1,000 would mean I'm going to move it over 3 spaces. So now I've got the number 333. But then I'm going to multiply it by another 1,000. So I could think of that either as adding 3 zeros to the end, or I could think of it as, oh, the decimal place is here right now, and I need to move it 3 more to the right and fill in with zeros. My end answer is 333,000 meters squared. So again, in your head, you could have just said, since there's 1,000 meters in a kilometer, I could scoot it over. For the first kilometer to meter, I would scoot it over 3 places. That'd give me 333. But then when I multiply by another 1,000, that would scoot it over 3 more places, or you could just add 3 zeros at the end at that point. I would kind of switch over to thinking about it that way. The deal about it is regardless, you got it on paper here, on your paper. If you're writing it down, this helps you keep track of it so you don't mess up. Because usually people, when they mess up with these, they go, oh, I knew better than that, and it's just that you try to do too much in your head. So this gives you a way to get it down on paper so that you're not trying to keep up with it in your head too much. Okay, so for number 6, we have 0.5 meters cubed, and we want to change it into centimeters cubed. Okay, so I'm going to write down what I have. I have 0.5, and meters cubed is meter times meter times meter. I'm going to put a little dot in between so you don't think it's millimeter or something weird, okay? Now, I need to get rid of each of those meters, so I need 3 fractions that have meter on the bottom since I had meter on the top, correct? Because that would cancel out that one. That one would cancel out that one. And this one would cancel out this one. Now, I want to get rid of meters, but I want to end up with centimeters cubed, so don't I need centimeters on the top of each one of these? That gives me 3 copies of centimeters, which is centimeters cubed. How many centimeters are in a meter?
100.
Yeah, that one's a math fact that most of us can remember a little easier. 100 centimeters in 1 meter. So I'm going to write it down on each one of those fractions. So what this, if you look, if I draw my fraction bar on my first term and put a 1 under it, in the denominator, don't I just have 1 times 1 times 1 times 1? Does that denominator even matter here? Do I need to write it down? Yeah, it's going to be 1. But on the top, here's what I have. I have 0.5, and there are 2 zeros here, 2 zeros here, and 2 zeros here. That means I'm going to move my decimal place over 1 space for each 0. When I move my decimal place over 1, 2, 3, 4, 5, 6 spaces, 1, 2, 3, 4, 5, 6 spaces. So my new decimal place will be here, and for every one of those little bumps I made there, I'm going to put a 0 to fill it in. So that's a 5 with 5 zeros after it. Put your comma in, you end up with 500,000 centimeters cubed.
That's much easier than I did it.
Did you get it a different way?
No, I did it like different, and I got it
In your head, you could have just said, well, it's, let me pick a different color down here. So this is if you were doing the same problem in your head. You could have said it was 0.5, and I move it over 2 places, but I got to do it 3 times because of the cube. So there's 2 places once, 2 places twice, 2 places 3 times. Fill in with a bunch of zeros everywhere you see a bump, and I still get 500,000. I need to make that look like a comma, centimeters cubed. You can do it faster just by saying, how many times do I move it over? Find out that number of times, and then multiply it by what your exponent is. I got to do that 2 times 3 times, which is 6 spaces to move it over.